Have you ever looked at a city skyline and wondered why there's a huge skyscraper on one block, but just a small house on the next one? Well, the answer isn't just about money or who owns the land. It's actually all about a single, really powerful number that shapes our cities, the floor area ratio. Now, it might sound a bit technical, but trust me, it's like the invisible blueprint for every single building you see around you.
So let's imagine for a second. You did it. You bought your dream plot of land. Now the big question is, what can you actually do with it? Are there any limits? Could you build a massive skyscraper? Or maybe just cover the entire plot from edge to edge? Well, the truth is, your freedom isn't quite that limitless.
The answer to how much you can build, how high you can go, and even how crowded your neighborhood will get, it all comes down to one simple but incredibly powerful number that's set by the government.
All right, so let's get right to the heart of it. How much can you actually build?
See, this isn't a number you just come up with on your own. It's a specific rule, and it's carefully decided by your local government's urban planning department. They're the ones who look at an area and decide how much development it can handle.
And the main tool they use to do this is called the floor area ratio, or FAR for short. And that's the big idea we're going to unpack today.
So what is it exactly? Well, to put it simply, FAR is just a ratio. It's the building's total covered area, and that means adding up the square footage of all the floors compared to the total size of the plot of land it's sitting on.
The formula itself, it's beautifully simple. You just take the total constructed area of your building and divide it by the area of the land. That's it. The number you get is the floor area ratio, and it's the number that controls everything. Okay, theory is one thing, but the best way to really get a handle on FAR is to see it in action. So let's run the numbers on a couple of real-world scenarios. All right, scenario 1. Let's say you have a 10,000 square foot plot, and the city says the FAR limit is 0.5, or you can think of it as 50%. The math is super easy. 10,000 square feet times 0.5 gives you a maximum buildable area of 5,000 square feet. Now, here's where it gets interesting. It's how you can use that 5,000 square feet. You could build a wide, single-story building that covers half your plot, or you could decide to build a taller, two-story building on a smaller footprint. That leaves you with more open space, like a bigger yard. See? The FAR gives you that design flexibility.
But what if you're in a much denser, more urban area? In that case, the FAR might be way higher, let's say 2.0. On that very same 10,000 square foot plot, you can now build a total of 20,000 square feet. That is 4 times more than our last example.
And once again, you have some strategic choices to make. You could build a 2-story building that covers the entire plot from edge to edge, or you could go vertical and build a 4-story building on just half the land. It's pretty clear. A higher FAR definitely encourages taller, denser buildings.
Now, you might have also heard another term floating around out there, FSI. This can get a little confusing, so let's take a second and clear up the difference between floor area ratio and floor space index.
So here's the big secret. They're exactly the same thing. No joke. Both use the identical formula. The only difference is really just how they're written down. FAR is usually shown as a percentage, like 200%, while FSI is shown as an index number, like 2.0. Same thing, different name. So, we know what FAR is, we know how it's calculated, but let's zoom out to the bigger picture. Why does this one little number matter so much for how our cities actually grow and feel? You know, urban planners don't just pick this number out of a hat. They look at a bunch of really critical factors. First, they analyze the current population density. Then they project future growth. You know, how many more people might live and work there. And maybe, most importantly, they have to assess the existing infrastructure. Can the roads, the power grid, and the water systems actually handle more people? So, when a government makes the decision to increase the FAR for a certain area, it sets off this whole chain reaction. And it has very real consequences for everyone living there. Yeah, increasing the FAR has some really clear effects. For starters, it encourages vertical development, so taller buildings. That naturally leads to higher population density. And when you have all those extra people living in the same area, it puts a lot more stress on the city's infrastructure, from traffic jams to how the utilities hold up. I think this quote sums it up perfectly. It really boils down to this. When the FAR of any place increases, the population density gets increased. More people will live in less area. It's really the main lever that governments can pull to manage how dense our cities get. And that brings us to the crucial question, doesn't it? FAR is a super powerful tool for growth, but it's also a really delicate balancing act.
As our cities just keep expanding, the real challenge is finding that sweet spot between building more and keeping our cities livable. So, the question we're left with is, how do we get that number just right?